What happens when two developers edit the exact same line of code at the exact same millisecond? Race conditions, overwritten data, and a crashed server. Today, we're tearing down the magic behind Figma and Google Docs to build a real-time collaborative code editor using Next.js 16 and CRDTs. Stopwatch Chapter 1, The Collaborative Text Editing Trap. Building a single-user code editor is simple: a React state variable, a text area, and a save button, but the moment two developers open that same code file at the exact same millisecond, everything breaks. User A types a function name at index 5, while user B deletes a line at index 2. If you simply push text updates to a database over HTTP, you get catastrophic race conditions, overwritten code, and cursor teleportation.so. How do platforms like Google Docs, Figma, and Replit allow thousands of users to type simultaneously in real time without locking files or destroying data? Welcome back to Behind the Abstraction. Today, we're building a real-time collaborative code editor using Next.js 16. We'll strip away the magic of real-time state, compare operational transformation versus CRDTs, and implement WebSocket edge routing using modern full-stack architecture. Stopwatch Chapter 2, OT versus CRDTs, the core math of real-time. Before writing a single line of Next.js code, we must solve a fundamental computer science problem: mathematical consistency across distributed systems. There are two primary ways to resolve typing conflicts: operational transformation, OT, used by classic Google Docs. Every key press sends an operation, like insert A at index 10, to a central server. The server acts as the absolute referee, transforming index positions and broadcasting the fix back to all clients. The problem: centralized OT servers are complex, memory-heavy, and difficult to scale horizontally at the edge. CRDTs, conflict-free replicated data types used by modern tools like Figma and VS Code Live Share. Instead of raw array indexes, every character receives a unique, globally immutable mathematical identifier. The magic: whether client A receives updates before client B or vice versa, the CRDT algorithm guarantees that both clients mathematically converge on the exact same document state without needing a central authority to resolve conflicts. For our Next.js 16 architecture, we'll use YJS, the fastest JavaScript CRDT implementation available. Stopwatch Chapter 3, Next.js 16 Architecture and Server Components. Let's look at the full-stack architecture powered by Next.js 16. We start in the app router. Using Next.js 16 React Server Components, we fetch the initial document state and user permission checks directly on the server edge. This eliminates layout shifts and guarantees zero waterfall initial page loads. Once the initial HTML hydrates, the client mounts a dedicated code editor component, like Microsoft's Monaco editor, the engine behind VS Code. Now, we mark this editor as a useClient component and bind its internal text model directly to our YJS CRDT data structure via a persistent WebSocket connection. Stopwatch Chapter 4, WebSockets and Edge Presence Management. HTTP request response cycles are too slow for real-time typing. We need a persistent bidirectional WebSocket connection. In our setup, whenever a developer presses a key in the Monaco editor, YJS captures the local delta, wraps it into an encrypted CRDT update binary, and streams it over WebSockets at 60 frames per second. To make it feel like a true collaborative editor, we also need present state live colored cursors showing where team members are clicking. Text selection highlights in real time. Presence data is ephemeral, it doesn't need to be saved to a database forever. Using Next.js server actions or edge providers like LiveBlocks or Partikit, presence updates are broadcasted via high-frequency UDP-like WebSocket channels. When a user closes their laptop tab, the edge server broadcasts a user-left event, instantly clearing their cursor from everyone else's screen. Stopwatch Chapter 5, Persistence and Edge Database Sync. Here is a classic system design trap. Should you write every single key press directly to your PostgreSQL database? Absolutely not. Writing to a database on every keystroke will instantly exhaust your connection pool and skyrocket your cloud infrastructure bill. Instead, we implement a debounced persistence pipeline, in-memory CRDT state, all active edits live inside the WebSocket server's memory buffer and client local caches, debounce sync every 5 seconds, or after 2 seconds of user inactivity. The server serializes the current YJS document state into a binary blob, uint8 array, database write. The server executes a background transaction using an ORM like Drizzle or Prisma to store the binary snapshot in PostgreSQL or Redis. If the WebSocket server crashes, the clients reconnect, exchange their local CRDT state histories, and instantly self-heal the document without losing a single character. Stopwatch Chapter 6, Summary and Senior System Takeaways. Building a real-time collaborative code editor in Next.js 16 boils down to 4 core architectural principles: decentralized state with CRDTs, use YJS to guarantee mathematical convergence across concurrent typists, hybrid server-client rendering, use Next.js 16 server components for instant document loading, then hydrate with client WebSockets, ephemeral presence channels. Keep high-frequency cursor coordinates out of your main database, debounced persistence, buffer typing events in memory, and commit binary snapshots asynchronously. Understanding these distributed state abstractions is what separates junior developers who rely on basic HTTP forms from senior engineers who design production-grade, real-time platforms. If you enjoyed this deep dive into real-time system design, hit that like button and subscribe. Drop a comment below. Have you ever built a real-time app using CRDTs or WebSockets? What system architecture should we dismantle next? Thanks for watching, and happy coding. To make this simple, here are the core keywords you need to master today. First, OT, Operational Transformation. This is the classic algorithm made famous by Google Docs. It relies on a central server to transform character index positions whenever 2 users type at the exact same time. Second, CRDTs, conflict-free replicated data types. This is the modern, decentralized approach used by tools like Figma and VS Code. Instead of relying on raw array indexes, every single character is given a unique, globally immutable identifier. And third, the YJS CRDT data structure. YJS is currently the fastest, most production-ready JavaScript implementation of CRDTs. It handles all the heavy mathematical merging in the background so your app stays fast and conflict-free.